So today we're going to start talking about the STL. Good, we're recording. We've used the STL a little bit. That's the standard template library provided by C++, so it's approved by the C++ standards organization. And we're going to really only talk about the basics of the STL. There are many extra features beyond that, beyond what's in here. Particularly into lambdas with functional programming, as well as some other multi-threaded tools. But we're really going to talk about the basics today, which should get us through the rest of this course. And the STL, the essential or beginning part of it, is divided into three parts. We have containers, algorithms, and iterators. So containers, that's aka your data structure. You know, a vector is an array, a list is a doubly linked list, etc., etc. Algorithms, a collection of algorithms like sorting, finding, searching, etc. And then iterators. Did y'all do iterators in OOP? Where you did like linked list dot iterator, which gets you an iterator pointing to the first one, and then while has next, get the next one, so forth and so on. All right, so there's a collection of iterators as well in order to iterate or go through a data structure. So today we're really just going to go through all the different ones, or the basics, I should say, of the STL, and then there'll be a little lab afterwards. And that should be it for today. So today will hopefully be more about a practical, or just more practice than anything else. Oh, hey, look, a diagram. You have containers, which compile algorithms to do stuff. And the algorithms, of course, need to use an iterator sometimes in order to iterate through your container. Great. Hey, wait, this is cut off. Huh, I wonder why that happened. All right, containers. It's a way to store data. Wow, all right. We've got a vector, doubly linked list, double-ended queue, a stack, a set. Oh, it doesn't tell you what set it uses. I forgot if you used a tree or a hash, a binary tree or a hash table for set, but I know math is a hash table, and we will get to hash tables, I think next actually. Hash table and associative array are very similar. Okay, so you have different types of containers. C++ divides them into different sections. So a sequence is one where you literally put something right after another. So aka vector and list. And did they tell you why they call them sequence? No? Okay. Maybe they'll tell you next? No? Okay. We talked about doubly linked list. That's what a list is. All right, an associative container is used not sequentially, but has a key to access its elements, typically a number or a string. All right, for example, a dictionary, or sometimes called a hash table, or an associative array. These are all going to be used interchangeably. The entries are ordered alphabetically, but you may access them differently. All right. So associative containers, you have two of them. One's called set and one called map. Please come and give me a picture. No, you don't? Well, that's annoying. All right, so a set. Y'all done a set in math? No? Maybe? Where you have a set of numbers, and then you can ask, is the number in the set? Or for every number that's in the set, do something. You can do unions and intersections, but the idea is a set only has a collection of numbers. Now a map maps a key to a value. So it may map a string to a number. Hopefully that sounds familiar, like Project 1. So one thing to try and use for Project 1 would be a map, although for Project 1 it would not work out very well. Lastly, for set and map, you have something called multi-set and multi-map. What that does is it allows you to have multiple items of the same value inside the set or the map. All right, great. Let's go actually start practicing on things. So we have a vector. Did we do this already in class at some point? Where you create a vector based on an array, has those 5, you can pop the back number to get 13, you can push 15 onto it, and then you can get anywhere in the subscript.
We made a vector for the last class, but I don't think we've talked extensively about them.
Alright, let's do this. Oops. Good old template, day17 STL fun. Alright, so did they make it a static? They did. Alright guys, give me some numbers.
5.
15? 19. 32 and 6. Alright, great. So we can create a vector, which has to be part of the STDs of course, of int, we'll call it vec of array, and then I think you pass it array and then array plus 5. Is that right? Yep. So, what is this?
As a deep copy, I think.
It does a deep copy, but notice what am I passing to the constructor of vector? I'm going to include it real quick. What's array?
A pointer.
A pointer, right.
To the first index.
To the first index. What's array plus 5?
Last index.
Close.
It's the last after.
It's the one after the last. So, and this is going to be a very common pattern in the STL, where you point to the beginning and then the end is the index right after the last. Now, let's see if we can print it. We know there's 5 elements, so we're just going to just put that out like that. Oops. Sub I.
Did you say 6 then?
No, 5. No. Yeah, you're thinking because I know how you got that, but remember, STL you point one after. Yep. Yep.
It's been a hot minute for arrays.
Let's go put backslash in. Let's make it. Oh, we probably should run it, shouldn't we? Hey, look at that. Beautiful. Okay. It's amazing. Yes, it is.
Nope.
Yes.
It's just the best thing ever, Paul.
Okay, let's not go too far. What was it? Pop? Oh, pop it back. So we'll pop the back. And then we'll print it all again. Oh, this is the problem with using C++ in the STL. So what's the error, guys?
Don't know, just doesn't like what we're doing.
Yep. Let's see if we can see it. Otherwise, we're going to have to decode the error novel. It's probably this thing. Yeah. It doesn't like something here. Let's pop back. Did I type in the wrong function? It says pop back there. Let's go bring up Firefox. Good morning. How you doing?
Tired.
Okay. Ethics paper?
Hopefully it's finished.
Pop back, push back. Oh, pop back is a void. So of course you can't send it to C out. That's the problem.
Don't be like
Yeah, you have to do peek.
blunt or something like that.
Notice that, that's hilarious. Even though I popped it, I wouldn't print it all the way up to 5, and it was still there.
Oh, it's doing the array thing.
Yeah, it's doing the array thing. So we actually need to find what vector's size function is so we can make our for loop, which is iterating through it, make more sense. Do we have size? Size, return the size. Hopefully this is
Resize.
resize if you want to make it bigger. So let's go back
You
up.
can use resize to make smaller?
Yes.
Hmm.
Let's see if that does what we want. Comparison between signed and unsigned integer and expression. Okay. Fine. Unsigned.
That's an unusual error. Oh,
Well, that was a warning. Yeah, it's a warning. Well, no, signedness is important because, what was it? If it's unsigned, you get 0 to a little over 4 billion. Unsigned, or I'm sorry, signed is negative 2 billion to roughly 2 billion. So there's an extra space difference. Did anyone sleep well last night? Oh, huh. I did not.
I rarely sleep well.
That
Oh.
shows our dedication to your class.
Okay. Wait.
That we've come.
Oh, okay.
Still.
Okay, despite your sleep deprivation. Okay. So we pop it. Hey, look, the 6 is gone. And then let's do a vec.push. What number do you want to push?
27.
27. Hey, look, I'm going to print it all again.
Do it again.
Oh, we got to push it to the back. There it is. All right, so we're going to be doing a lot of this. So I'm going to go ahead and make a function for all this. I'll call it vector fun1. That way I can just do this. Oops, that is not what I meant to do. And then I can just call vector, probably need to spell it correctly, fun1. Run it. Hooray. Now I can comment that out. Beautiful. All right, any other questions about what I just displayed or demonstrated? Beautiful. We're going to keep doing this. Oh, hey, look. It's how you print it. Thanks. Oh, that's interesting. All right, we'll do that.
What's interesting?
You can keep popping the back, so it's like a Q almost.
Yeah.
And so you can do while not, was it vec dot, is it just empty?
Yeah, that.
Yeah, just empty.
You're
That's
missing
not
a Y.
Y for empty.
Oh, thank you. For some reason I thought you were talking about the while statement. I was like,
Oh, no.
statement doesn't have a Y, while doesn't have a Y in it. What's going on? And then you have to pop the back, don't you? Oh, you print the back and then pop the back, sure. So that gets the last one. And then you can do pop back. All right, guys. Let's change this to fun 2 real quick. And then all right, so what is this going to output?
In reverse order?
Right, so more explicitly, what numbers are it's going to print out?
6, 32.
6, 32, 19, 15.
All right. Let's find out. Nope, it says error.
Huh.
Bet you didn't think that was coming.
I considered it.
You considered it, but you didn't tell me. I forgot to put copy.
Well, I didn't consider it enough to say it out loud.
I think you need more. What's the word? Confidence. I don't know.
Yeah, I mean, you're not wrong, but that's pretty low on my list of priorities right now.
Confidence.
Yeah.
It's even on
Oddly
your list.
enough, there are more important things I have to do right now
Like
than
the
to
ethics
deal with
paper?
my own personality. I'll deal with that during lunch break.
Okay. All right. Hey, look, that's another way to iterate through the vector, although you're removing all the elements one by one, so that's fine. All right, so constructors for vector. Notice that we're templating. Right now I'm only templating on integers. You can template on whatever you want. Hopefully this is pretty burned into your mind, since pretty much every lab is using templates. So if you just pass it an integer, it creates a vector of that size. If you give it a number and then the data type, it'll initialize all elements to that type. So for example, you have 10 dates, you can tell them all to be December 17th, 1999. Were any of y'all not born then? Ooh, we're almost to that point, aren't we?
Or
Wait, 98 or 99?
99.
yeah, I was
Really?
I was born before then.
Born before then, 1999?
I was born then.
I was born at the beginning, so
Yeah.
yes.
Okay, wow, we're almost there. Oh, so y'all don't remember the whole Y2K thing at all?
I don't even know what
Yeah, I
that is.
don't know what it is.
So no.
I've
I've heard of it. I don't know
It
what
might
is.
just not be
Explain
from
it.
memories.
Computers? So,
So like the end of the
in the
world.
60s, and we all remember the 60s.
I was there.
Neither was I, but we all remember it. Wink, wink. So, in the 60s, they decided that in order to store the date, they were just going to store 2 digits, the last 2, because obviously the first 2 are 1 and 9. Why would you need to store those digits? So they just store, like 65, 67, 68, so forth and so on. Oh yeah, you know where this is going. And then all of a sudden 1999 came along and they're like, wait a minute, if we change it to 00, it's now 1900, but then it'll be 2000. And everyone thought that banks were going to explode because how could you, right.
Okay.
Everything's going to be in the past now. So everyone got really, really worried. I'm not kidding, people would buy food insurance so that they could own a portion of food in case the entire world's economy exploded overnight, so that they would at least have food to live for a little while until people recovered. I'm not making this up.
I mean, I can't fault them for that. Like computers are new enough that where I can believe that anything can happen. Is
Well,
basically-
even nowadays, you go on a farm. It's not like every plant has a computer chip inside of them.
Yeah, but
So the plant's still going to grow.
yeah.
But you
And-
might lose your entire bank
The food's still there.
account.
And cars, I mean, they had computers in them, but they didn't carry dates.
Look. I guess I mean to say I respected those individuals' drive and their foresight. I don't quite understand their thought process.
Right. So a lot of people stayed up to see if the world would explode. I went to bed at 10.
That's a very weird problem to have.
It
If
is.
it did, what would you do? Why does it matter?
Why what?
Like if it did explode, what would you do?
You can't do anything about it anyways.
Right, exactly. So I went to bed at 10.
Yeah, that seems
Stayed
nice.
up a little late, because I usually went to bed at 9.
I watched some cartoons.
Isn't that the highlight of your weeks?
I forgot what day
My
of the week.
bedtime's at 10 today.
Yeah! And then some of my friends went out and interviewed everyone about if they thought the world was going to explode. Yeah. Whatever.
Did they feel dumb when it didn't explode?
They're still hopeful that computers will crash.
I rolled my eyes at them. How about that? Does that count? Yeah.
I think I would roll my eyes so hard and I have to go back into my skull.
Hmm.
See, the one I remember is everyone thinking the world's gonna end in 2012.
Oh, yeah.
That was funny.
Was that the Mayan one?
Yeah.
Yeah.
And it was also that movie that was just like, oh, the world's gonna end, and it's like, okay,
I mean-
cool.
That would have been so bad.
Well, the thing was, they said that was like the first part of the Mayan calendar. That
Mhm.
like that's the first cycle. Then you go to the next cycle, and it's just like, really, the first cycle's done.
So we're all going to believe in Mayans now. That's what you're saying.
They created
Yeah,
a
we did
calendar,
believe in him before. But I don't know.
Right.
but they're all dead. So
Guess we
Yeah.
gotta believe in something.
It was the Aztecs that did the human sacrifice, right?
I
Yeah.
think so.
Yeah, I'd
I
have to
don't
go.
know, mine's probably did something.
Yeah,
similar.
probably mine's probably did
I'm
that
gonna
too.
go with that.
Which god would you like to sacrifice to?
All of them.
Oh, y'all didn't watch the Animaniacs, have you?
The one
Oh, I
left.
love that show. The Animaniacs?
I think I've heard of it.
It's, wait, did y'all watch Looney Tunes as kids?
Oh,
Yes.
yes.
Okay, good.
I
So,
look, you must have seen
Animaniacs is like that type of,
We're not that uncultured.
look,
Well.
I don't remember, alright? I don't think my kids have watched Looney Tunes yet. I don't know if they're going to because, well, there's no Saturday morning cartoons anymore.
Yeah, there is.
Boomerang.
Boomerang?
Yeah.
I don't know, I'll have to, maybe I'll have to introduce them at least. a little.
Boomerang's got all the.
But anyways, Animaniacs.
Uh,
It's the same style as the Looney Tunes, except for they make fun of course, Looney Tunes and everyone and everything. And then one of the ones they decided.
They were like a more family-friendly South Park.
Oh,
you know,
Yes,
like-
way more family.
Like they made fun of like
bunnies.
pop culture at the
I
time.
don't know, the Yakko Warner.
I've seen that before.
It's great. Oh, it's a great show. So one of them they started to, because they have a history in it. So they were making fun of, I guess, the Aztecs or the Mayans. So they'd be like, all right, well, today it's your turn to be sacrificed. We have plenty of gods. Which one would you like to choose right before we throw you into the volcano?
Oh, I do remember that.
Yeah.
It's a great show. Oh, it's a
I
beautiful
didn't know
show.
the name of it.
Oh, it's a beautiful show. That's where Pinky and the Brain came from. All right. Whew, let's keep going. Next comes iterators, and I always forget how to do iterators in C++ because they're kind of weird.
Yeah,
Here we go.
I don't like them very much. I mean, they're useful, but they are annoying to do.
Yeah, unfortunately, they're very important, and we'll hopefully I'll show you soon why that's the case. All right, let's pretend I actually remember how to do this. So, vector sub int of iterator, because every STL class has a subclass called iterator, so you can actually grab the iterator for that class. Notice that since it's part of the vector, the iterator will change based on your template. We'll call it I. Called vec.begin. That gets an iterator, the beginning, an iterator pointing to the beginning, and I keep forgetting if I need to put a star in front of that. I hope I don't.
I think
Well-
you forgot. Yeah, never mind.
We'll find out really soon. Let's see if it throws any errors. Oh! Well, let's actually call the function.
That's probably a good idea.
Wow, I did it correctly the first time.
Look at that.
Nice.
Nice. All right. So if we want to print something, we go star I. Because the idea of an iterator is it's supposed to behave like a pointer, even though it isn't at all, but it's behaving like one. So it points to the first one, while you're not pointing to the last one, keep incrementing the pointer. If you want to get the value, you dereference it.
It's like a ditto from Pokemon.
Oh yeah.
Transform into whatever it wants.
If I was 1 or 2 years younger, I'd be all about Pokemon.
I was the one I
Why are
watched
you
Pokemon.
not?
1 or 2 years younger?
No, why aren't you into Pokemon?
Because when it came out, I was basically a teenager, and I had played Final Fantasy, Chrono Trigger, all these other RPGs. So when I started playing Pokemon, I was like, this is way too simplistic, and it's not that much fun.
I like the older games. I don't like the newer ones. They're just,
Yeah, I stopped playing after
especially when
Black
they
and
started
White.
putting fairy Pokemon. Like,
Fairy Pokemon?
Yeah. Fairy Pokemon. When fairies are strong against dragons.
What?
Hate
Which I hate.
fairies. Hate them.
Hate those
The
fairies?
good always overturns.
They only have two
Fairies
weaknesses,
don't
and it's
use
like two
dragons.
of the least
Yeah.
useful
No.
types to fight with.
I'm sorry whoever's watching this video, we're getting off topic all the time, but I think it's just because it's Wednesday and we know this topic is not going to be too hard.
I don't know, Monday was a little crazy too.
Monday was, oh, it did?
Yeah.
I don't remember.
Yeah, conveniently, if you press
my
the
favorite.
right, what's the word? No, it dawns on me. I don't know.
So
right
look, I
arrow.
did this right. And if you watched it, it actually printed all the values 5, 15, 19, 32, and 6 using an iterator. The nice thing about iterator is this interface is implemented amongst all the containers that you have. So you have a way to iterate through every single container that's out there with this interface. Yes?
Couldn't you also just switch the beginning and end and then it prints in reverse too?
As long as you do I minus minus.
Minus minus.
Yeah, so let's go do that because that's a great observation. Although you really need to be end minus 1, right? Does not equal, and then here you're going to have like begin minus 1. I think that's the way it's going to work. Hey, let's find out.
Forgot a parenthesis.
Yeah, sure did. Hey, look at that.
Wait, so why is it minus 1 for the beginning?
Because when you're at the beginning, you're okay.
Mhm.
It's 1 before the beginning when you don't want to go back anymore.
We don't want to go to -1.
Yeah.
Right, you don't want to go -1, but 0 is
Yeah,
just fine.
that'd be bad.
Sure. Depends on what you're trying to do. If you want to have your program correct, that's bad. If you're trying to break someone's code,
Yes.
I just want to ruin everything.
yeah.
I just switch this little thing here.
Oh, by the way, you are allowed to have multiple iterators going through an object at once. I am not going to go through this example, but just know that you may have all sorts of iterators. And they can go both, well, depends upon the container, which direction they can go. Let's see if we talk about that. Nope. All right, that sounds great. And this is exactly the code we just did. This is again the code we just did. But notice that max is being passed 2 iterators, and it just deals with the iterators, not with the data structure. Do y'all see this? You pass it, the iterator point to the beginning, the iterator at 1 after, aka the end. So you just keep going forward with start until you hit stop, and then you're done. This is just to show you another way to use it. I don't see a practical application of this, but this is just to give you,
Just because you can.
you really can, just to make sure you understand iterators a little better. Hey, more iterators. Let's see, did we do this one? This is what we just did again. Okay, this is what I was talking about earlier. Not every iterator can be used on every container. For example, of the basic containers, well, the real ones, we're not going to talk about input output. Forward means you can only do plus plus. Bidirectional means you can do plus plus and minus minus. And then random access means you can actually jump all across the iterator if you want to. Most of the time you're going to be dealing with bidirectional with iterators because that's the point of iterators. But there are some random access ones as well. Hey, there's a for each. Where are we? Now, I'm not going to test you on this, but it is important to show because the for each function does become very important later on when you're actually coding in the real world. So for each, and I forgot the syntax because I don't get to use it too often. All right, that's right. Vec.begin, vec.end, and then I'll call it the show function. Sure, we'll stick with that. Then you create another function called show, and you should be passed an integer, right? Yeah. All right, so create the array for each starting at the beginning to the end, call the function called show, and then see out. Ooh, I bet you this is not going to compile. Yeah. you have to include something called algorithm, but you're still not going to compile. Oh, it did. Great. Does this look familiar, by the way?
Yes.
Yes. What does it look like?
Something I looked at for my project too.
For Project 2. Project 2? Wasn't one of the labs? Project 3 has this, as well as one of the labs has a function pointer into it. So the for each is calling your function on each of the values. All right. Here's an important question. What's the order that it goes through?
From beginning to end.
Now, does it have to?
You can do end to beginning. Maybe.
Sure. Well, my point is the for each, semantically speaking to us, because you're just calling this on each element. It doesn't actually have to be done in order. Now, C++ on a vector does it in order, but some languages don't do it in order. What can anyone think of an advantage of not having to do it in order? This is going to be kind of a tough one.
You could, like you could start anywhere.
Yeah, well, yeah, you could do the 1 at 0, 1 at 3, 1 at 4, 1 at 5. It doesn't matter what order they're done in or what order they're completed in. How about that?
If you're trying to randomize the list.
Okay. It has to do with what all our machines, pretty much all our machines are nowadays. We have, all our machines today are multi-core.
Oh, you can run them, like, you can do it, different processes at the same time.
Right. So one nice thing about a for each that does not guarantee order is that you could, if let's say your vector is huge, or let's say the show function is incredibly complicated and takes a long time to complete, the compiler, if it was a different semantic, could chop this up automatically for you, throw them on different cores, and automatically take advantage of the multiple cores on your machine. Now, C++ doesn't do that right now, but some languages do. So keep that in the back of your mind. Because when you take operating systems, you'll find out very quickly that multi-threaded programming is very treacherous. But this is an easy way to take advantage of it. All right, any other questions, comments? Great. The find algorithm, all right. Okay, and what number do we want to find? 19? Great. Does that give us the index? Oh, it gives us the iterator, that's right. So you get so, in other words, if position equals vec dot end, ooh, and that's a big error. What's the big error I just made? Huge error. Don't see it? Great.
What?
Big error. Yep. Is this going to compile and run? Yes. Oh, it will compile and run.
It just doesn't work right.
That's correct. What does it do instead?
It reassigns.
Yep. So what's the output going to be?
Not found.
Not found. No matter what, the answer will be not found. Let me run that for you real quick. And the compiler will not tell you. Oh, maybe it will. Nice, it tells you now. I also need to call find, so let's do that first. Ooh. Could not convert. Wow. Let's give a little clap for C++ on finally fixing this. That's nice.
How long has that been an issue?
They heard
Decades.
screams.
What's that?
They heard your screams.
You heard my screams?
It's like, oh no, Dr. West is talking about this issue again.
Let's go fix it.
Been like 5 years now.
Oh, we probably should call the function.
Yeah.
Whatever.
That'd be a good
That'd be
idea.
helpful.
Well, I did all the work. Do I have to really turn it in? Alright, so found. Alright, so you can call the find function. That does a linear search. Find if. Oh, you can also create a test. You can create a function to test everything. Alright, so we'll do that as well. This time I'm not going to fall for it. Aha. We'll call it bool in range. Oops. Yeah, 15.
Why is it Van? Yeah.
Why what?
Why is it Van?
It's just one of those mornings. So it's going to call in range for every element to see if it can find one that's within the range, or find one where when passing it to the function in range will return true. In range is testing if the value is greater than 10 and less than 16. Does that exist? Yes. Bless you. All right, let's go change this real quick to a 15 just to show that it is working, because then it should say not found, because that 15 is not strictly less than 15. Move back to 16. How are we doing? All right. Count if will count the number of elements that return true on the test function. I'm not going to do that. I think y'all got this, right?
Yeah.
Good. All right, so that's it for the vector.